Okay, we're given an equation, which is what type? What's the parent function? Yeah, Andrew. Good. So this is a cubic function. Okay. How do I know what to graph? What do I do? Yeah, you. Look at the domain. So the restricted domain's from 0 to 3. Okay. So you would take 0, start with x equals 0. Okay. So what is my first point on this restricted domain? John? -7. Okay. So we have 0, -7. Is that going to be an open or closed circle? John? Open because it's a parenthesis. So we'll do 0, -7. Okay. All right. Then we have another x value of 3. Okay, that's just our two bookends for this restricted domain. So we have 3 is 2 cubed plus 1. What is my other y value being used? Yeah. 2. Is this going to be opened or closed? Yellow. Closed. Good. So 3, 2. Now, if you had to find additional points, okay, to show any sort of shape of this graph, okay, we know an additional one, which is what? The HK, which you're getting at, it's the point of inflection, which would be what? Good. 2, 1 is our point of inflection, which is between 0 and 3. So 2, 1. Okay. I also know that. I know this guy as well. Okay. And that's all I see of this graph. That's the only piece I see of this graph. Okay. So, were there any questions you guys had on the few problems you had for homework? Yeah, Grace. Okay. Number 7. Okay. We have x plus 4 squared minus 1 on the domain from -5 to infinity. Okay. So, we know two things. We know that we have to start with -5. So we're going to substitute in -5. We have -1 squared minus 1. What do we end up with? Anybody? For that matter. -1 squared minus 1. Yeah, Sam. 0. So we know 1 point, -5, 0. And that's going to be an open circle. Okay, -5, 0. We know it's open because there's a parenthesis. We also know the vertex is what? Because this is a quadratic. Yeah, Rory. Good. Vertex, -4, -1. Okay. I also know this graph is from -5 to infinity. So if this is my lowest point, the vertex, right? If it's -4, -1, do I also know -3, 0? Yep. And I could keep going by either A, entering x values that are greater than -5, or B, remembering the trick, because the A value is 1. Up 1 to the right and to the left, then up 4, 1, 2, 3, 4, and over 2. Okay, only on the right side because I can't go past -5. So this creates part of our quadratic function. Okay, makes sense? What is our resulting range from this? Andrew. Awesome. Good job. Thank you. All right. Any other questions? Okay. We are going to turn to number 2, which is on page 6 at the top. Okay, we're going to create a piecewise function, okay, all together. Okay, piecewise function all together with different restricted domains. Okay, so there's a number of ways you could do this. All right, you could start with original way, which I've taught before, is create your boundary lines, which are given to you in the domains. But since we've really been just plugging in values, we should start there. Okay, so when we have x plus 3, when the domain is from -infinity to -2, that's also x is less than -2. So I suggest you write down the inequality as well. All right. So what is my starting point for y equals x plus 3? What is my starting point for y equals x plus 3? Andrew? Be careful. We want to plug in -2 first. So our first point is -2, 1. Okay? So to start these graphs, you want to plug in whatever's given to you in the domain. So -2 plus 3 gives us 1. So -2, 1, is that going to be an open or closed circle? Well, open because there's a parenthesis and no line there. Okay? So this is open. Okay, so -2, 1. Okay, -2, 1 is there. Now, how do I know what direction this graph is going in? What can I do? I could do 2 things. Corey? You could graph the slope, which is what? It's 1. However, if I was to use the positive slope, up 1 to the right, you would graph in the opposite direction because I cannot go past -2. Okay? So down 1 to the left, down 1 to the left. Or we could simply plug in x values less than -2. So for example, -3 plus 3 is 0. Another point would be -3, 0. You could do either or. Okay? One way to keep in mind, if you know it's a positive slope, up 1 to the right, think of the opposite, down 1 to the left. Okay? That's your first graph. Now we have y equals 2x from -2 to 3. Y equals 2x from -2 to 3. Okay, so if I was to write this inequality notation, this is what it would look like. So what would I do here? What do you think? Use your heads. What do you think? Andrew? Yeah. So I would plug in to -2, -4. So I have a first point of -2, -4. Would that be opened or closed? Laurel? Closed because of the bracket. Okay, then I could also do 2, 3, which is 6. So I have 3, 6 as my other point. And would that be opened or closed? Go ahead. Open. Okay, so -2, -4, and then 3, 6. Okay, you could do a number of things here. How can I get from this closed point to this open point? What can I do? Yep, good. Just use the slope up 2. Perfect. Good job, Andrew. Or you could plug in x values between -2 and 3. Okay. And the last one is a quadratic, and that means when x is greater than or equal to 3. Okay. So what would I do here? Yeah, Laura. Good. Yeah. So plug in 3. Yeah. Okay. Oops, this is supposed to be 5. I changed it, you guys, so it wouldn't be. Okay. So my starting point is what? What is the first value I'm starting with? Sam? Careful. Other way around. 3, 7. 3 is what you input. 7 is what you get. Okay. 3, 7. Is that going to be opened or closed? Closed. Okay. 3, 7. Okay. What other point can I also graph? Yeah, which is? This is the updated one. So you know, sorry, I forgot to change it here. 5, 3. Yep. Because this graph would have been off the graph if I kept it as blah, blah, blah. So 5, 3 is the vertex. Okay. Right. I also know there's a matching point. If I'm 2 away here, I go 2 away to the right, up here as well. Okay, so let me fix this. That is your piecewise function. You took 3 graphs over 3 specific domains, restricted domains, and graphed them on one. Okay, that's how we ended last class on Thursday. Okay, so again, 3 graphs on 3 different restricted domains. However, one has open, one has closed, one has open, one has closed. If they were both closed, would it be a function? No. Now, there could be an instance where you get the same starting point or the same value somewhere, where one's an open circle and one is a closed, but it's at the same point. Closed overrides an open. Okay? So say, for example, instead of 3, 6, say if that was 3, 7. Okay? This closed circle overrides the open, so it would just be a solid point. Okay? What is my domain of this function? Yeah. Good. Negative infinity to infinity. What is my range? What would my range be? Yeah, Campbell. Good. It would be the same because you have arrows in opposite directions. Intervals of continuity would be different if they would ask you. Okay? Yeah. Andrew. Doing it. Yep. Yeah, it would still be the same. Yeah. Great question. The only thing you don't want to see is two closed on the same x value, because then it won't be a function. You primarily will only see 2 points, because if there was a third one here, then it would cross somewhere along the line, so we kind of space it out. All right? Let's try number 3 together. Okay? At the bottom here. Okay. And again, do you have to do all these pieces spaced out like this? No. Okay, it's just understanding the concept. Okay, so that first one, f of x equals 2, when negative infinity to negative 4, so it's x is less than negative 4. What type of graph would that be, Brian? On the one we just did? No. Wouldn't be that type of graph. Okay, Grace? Yep. This would be a horizontal line. Okay, little indicator here was y equals 2. Okay. What would be my starting value? Josh? What point? What point would it be? Negative 4, 2. And Josh, would it be opened or closed? Good. Awesome. Open. So negative 4, 2. What direction would this graph be going in? Left or right, Jackson? Because it's a horizontal line. Left. Good, because it's the x value is less than negative 4. Okay. So we have a horizontal line going to the left. Okay. Then what type of graph is next? The second piece is what? Mustafa, what would it be? Good. Absolute value. Move this stuff so we could see it. Absolute value. And this is from negative 4 is less than or equal to x, which is less than or equal to 0. So we could have 2 bookends, right? What else does the absolute value give us? Yep. Vertex, which is what? Negative 3, 1. So the vertex here is negative 3, 1, which is in between that range there, given to us. So we could plug in, yeah, Liz. Yes. Yep. HK for absolute value in quadratics, right? Square root is your starting point, HK. And cubics are your point of inflection, that dip. Okay? All right, so we have our vertex of negative 3, 1. Oops. Okay, but we're given 2 values. So we could plug in negative 4 when x equals negative 4. what is my corresponding y value? -4 what? 2. Again, this is what I was talking about before. Did we already have an open circle in -4 too? Right? So now, since this is included because it's a bracket, I'm going to fill it in. Okay? And then I'm also given x equals 0. So when I plug in 0, what do I get? Yeah, Sam. 0, 4. So we have 0, 4, and that is also closed. Okay. In order to show this shape, which is absolute values, what kind of shape? A V, right? What can I use for absolute value only? Yeah, you. The what? The matching points. We could do slope too here. Okay, so we have 1. Okay, so it looks like a V. And our last graph is from 0 to 6. Okay, find those two endpoints. All right. When x equals 0, Gavin, what do we get? -4. And is that going to be open or closed? Open. Good. So 0, -4 is open. And then 6, what? Lizzie. What did you get? Sorry. -1. Good. So we have 6 times 1/2 is 3 minus 4. -1. Okay, so 6 to -1. 1, 2, 3, 4, 5, 6. And that's going to be open as well. In order to connect our points, we could use the slope, which is 1/2. Up 1 over 2. 1 over 2. Okay, there we go. Awesome. Okay. What is the domain of this graph? Andrew. Good. Domain, -infinity to 6 with a parenthesis. Okay. What is our range? Yeah, Sam. Careful. Careful. Yeah, Charlotte. Good. Okay. Because we have values that are not being used there. Charlotte, nice job. So -4, -1 in parentheses, so that covers that first line. Then there's a jump from -1 to 1. So union 1 to 4. Awesome job. Okay, good job. All right, any questions? So now we're going to work backwards. Now we're going to work backwards, creating a piecewise function given a graph. Okay, we're going to work backwards. So what I want you to do is imagine these little pieces Green is like my first graph here, okay? Blue is probably the easiest graph to figure out. And then 3 is my other, okay? So how do we find equations of lines? You could either pick 2 points and find the slope, or see if you could find the slope given the graph, all right? So I want you to take 2 minutes to find these 3 equations. Use your notes to help. Find these 3 equations, okay? Take 2 minutes. If we get stuck, that is fine. I want you guys to try it. Okay, let's go through this. Who has the equation of the first line? Campbell. Y equals 2x plus 5 is correct. How many of you did get that? Okay, if not, I could choose negative 2, 1, okay, as well as negative 3, negative 1, okay, to help me with determining the slope, okay? If this is a surefire way to work, okay? It has to be a definite point, though. If it's in between or slightly off like this one is, then you won't get the exact slope, okay? So we have negative 1 minus 1, and then we have negative 3 minus negative 2. So we have negative 2 divided by negative 1, which gives us 2. Okay, so our slope is 2. Then I could take one of these points and use y equals mx plus b. So if I use equals 2 times negative 2 plus b, negative 4 plus b equals 1. I add the 4 to the other side to show that my b value is 5. So putting those two together, you end up with 2x plus 5. Okay? I'm also going to include it when you write a piecewise function. This is what it looks like. All right? So I have 2x plus 5, and I go in order from least to greatest. What is the corresponding domain that fits this? Yeah, Rory. Good. And negative 2 is going to have what? Bracket. Okay. Awesome. Now my second equation is what type of line? Yes, Brian. Horizontal, so it's y equals what? Y equals 3 is my other equation. And from what x value to what would it be? Yeah, if you. Good. 2, 2 with parentheses. Okay. The last one, I saw a variety of different answers because if you used this point to find the slope, so for negative 1, it's not actually on completely negative 1, okay? So you had to use that open circle in this as well if you tried the slope, okay, to find the slope. Any takers on that? First of all, is that going to be positive or negative slope? Brian? Negative. Okay. Any takers with this value? Keep in mind, negative 4 is not exactly on negative 1. Okay? It's slightly to the right. If it was, it would be an easy slope to find. Yeah. Okay. Any y-intercept? You're close. It's okay. It's all right. So your slope is correct. Okay? So y equals 5/2 x. Okay? So what, did you use points or did you kind of estimate? Yep. Okay, so to help you with the y-intercept, since the graph is shorter and you can't really see what the y-intercept is, I'm going to use this point here, which is 1, 2, 3, 4, 5, 5, negative 3. Okay, so if I do this, right, did anyone come up with a different y-intercept at all that had the same slope? John? 9.5? Okay, anybody else? Come up with something different or the same? So we have negative 3 equals negative 25. Oops. Okay, when we add 25 halves, right, what do I have to do to this negative 3? What do I have to change it to? Yeah, Brian. We multiply top and bottom by 2. So we have negative 6 halves plus 25 halves. What's negative 6 plus 25? So we have 19 halves, which is roughly what decimal? Yep, 9.5. Okay, which is exactly what John got. So we could put, all right, that's our equation. And this is not a nice one, but you have to use your slope or 2 points to figure out what your exact y-intercept is. And what would my restricted domain be for that one? Yeah. 3, 5, and parentheses with 3, right? Okay. So 3, 5 brackets. It seems like, looking around, okay, that we could determine the domain no problem, right? How many of you agree with that? I do. Okay. I could also tell that you guys are pretty good with finding equations when they're not so funky like this, right? But you got to remember your Algebra 1 skills in terms of finding equations of lines, okay? If you know the slope, there has to be a y-intercept unless it goes through 0, 0, right? But this case, it doesn't. So don't always rely on this graph is shorter. So to be exact, you have to go through the motions by using y equals mx plus b. Okay? All right? We will, when we get back from lunch, there's one thing I want to do first. Okay? When we get back from lunch, we're going to jump right into you guys trying number 2. Okay? When we get back from lunch. But first, I want to look at the bottom of the page where it says evaluate. Okay? You're given a piecewise function over certain restricted domains, and you have function notation. How do you know which equation to use? So for example, if I want to get h of negative 8, so that means x equals negative 8, which one would I use? What domain does negative 8 fit into? First, second, or third? Yeah, Sam. The first one, negative 8 is less than negative 7. So that means in order to evaluate, I am substituting in negative 8 into that equation because that's where it fits to get my corresponding y value, which would be what? Campbell? Negative 40. Good. Okay. The next one, h of negative 5, which one does it fit into that you will have a corresponding y value to? First, second, or third? Andrew? Why? Perfect. Yep, good. You did it right. So 4 times negative 5 minus 3. Since negative 5 is equal to here, we plug it into the third one. What is our corresponding y value? Brian? Good. Negative 23. And the last one before we break for lunch, h of negative 6 falls into what equation? First, second, third. Phoebe. The second one, because negative 6 falls in this category. So 10 over your corresponding y value would be negative 5. All right. All right, you guys. We will stop there. And you guys, what is our first equation? So we always go left, right. Sam? Good. A lot of you did have this. Okay, y equals 2/3 x plus 1. Okay. What is our domain? Someone else. Brian? Good. Negative 3 is going to have what? Awesome. Good job. Equation 2. So it's this guy here. What would equation 2 be? Andrew? Good. Y equals to x plus 3. And someone else, what is our domain? Campbell? Good. Awesome. And then our last one should be very straightforward. What is our equation? Laurel? Y equals 3, and what's our domain? Good. Thank you for doing that. 2 to infinity. So we have our 3 equations. We have our domain. So to write it as a piecewise function, 2/3 x plus 1, negative infinity, negative 3, x plus 3, negative 1 to 2, and then we have just 3 from 2 to infinity. Awesome. A lot of you guys had the majority of this. I think the first one we had a little difficulty finding. Okay. You could either connect this first point to this arrow or use this point and where the arrow is for an exact. Okay. Any questions? Okay. All right. You turn to this page. We're going to look at number 2. This year, we are not doing creating the equations based off the word problem. It's just evaluating. So if I was to give you number 2, a cell phone company uses the function below to determine the cost C in dollars for gigabytes of data transfer. Okay. Find the cost of using 1.5 gigabytes of data and the cost of using 4. Okay. So you have 2 questions going on. The first one, if we wanted to find the cost of 1.5, which equation would we use, the first or the second? Remember, your equations are to the left, your domain is to the right. 1.5 fits into what? Charlotte? Be careful, be careful. 1.5, okay? These are right here, your domain. This is the gigabytes. Oops. God bless you. Okay, so 1.5 fits into what domain, the first or the second? So pretty much the same thing as evaluating, but now we're looking at a word problem. The first one, so it will cost for 1.5 gigabytes $25. Okay, so for 1.5 gigabytes, it will cost $25 since the domain is between 0 and 2. Okay. Now the next one, how much would it cost for 4 gigabytes? Which equation would I use? Grace? Good. The second one because it's greater than 2. So we have 25. So the cost of 4 gigabytes would be $45. Okay, so the equations are done for you. You're just reading the information given and then deciding which one to use. Okay, so if we look at number 3, in a certain country, income tax is assessed by using the function below. F of x is the percentage of income that must be paid as tax, and x is the amount of income. Okay, so for A, if your income was 28,000, if your income was 28,000, which percentage of tax would you pay? 12%. So then it wants to see what amount of tax would you pay. So if we know 28,000 falls into the 12% category, what do we have to do to find the actual amount of how much we're going to pay? Yeah, Brian. Perfect. Excellent. So to find what amount of tax you will pay, 28,000 times 0.12, which would be how much in taxes? Could use your calculator. Okay. So 28,000, just to reiterate, falls in the 12% category. So what is the amount that you will have to pay? It's 12% of 28. Yep. Good. So you will pay this much in taxes. Okay. If your income was 14,000, what amount of tax? Andrew? 0. 0% means 0 taxes. Okay. C is a good one. Your income last year was 25,000, sorry. And your friend's income was 32,000. How much more did your friend pay in taxes than you? Okay. So, for 25,000, what percent would be used for me? John? 12. Okay. So for me, 25,000, 12% in taxes. Okay. So how much would I pay in taxes? Brian? 3,000. Good. That's mine. And now my friend. 32,000 would pay what percent? Who said it? Brian? 18, because it's greater than 30. So How much does your friend pay in taxes, or my friend pay in taxes? Phoebe? Okay. So your friend pays that much. I pay this much. What's the difference? How much more does my friend pay? Yep. So my friend pays $2,760 more than in taxes. Okay? So the difference here is you guys do not have to create these equations. They're given to you. Okay? They're given to you. You just have to know which one to use and how to evaluate. Okay? Does that make sense? Okay? So we went through all of the piecewise today, which was graphing piecewise functions all together. Okay, graphing piecewise functions all together, creating equations given a graph, creating a piecewise function, and then evaluating given a word problem scenario and equations. Okay, so we just finished the piecewise lesson. Okay, so if you could turn to page 10. Okay. And I'm going to write in class, for right now, in class, starting on page 10. And this is in class because you guys will finish. 5 through 7. Okay. There's multiple parts. And then homework, okay, starting on page 12, is the 1.6 practice 2. Okay. So these questions on page 10, you should finish in class. Okay, you should get those done. They shouldn't take that long. Okay, 5 through 7. And then the 1.6 practice 2 is your homework. Okay, make sense? Yeah, Sam? Yeah, so including, yeah, up until the review. That's okay. All right, up until the review topics. So what is that, Sam? 1 through 10? Thank you. 1 through 10.